Hello everyone, welcome to Olympiad Geometry. Today we're going to learn another example of using the Menelaus theorem. Let's see the problem. Let ABCD be a convex quadrilateral. Let's draw that. A, B, C, D. Diagonal AC intersects diagonal BD on point M. So AC intersects BD on point M. A line through M in parallel with AD intersects segment AB and CD on point EF respectively. So we draw a line through M and in parallel with AD. So this is E, this is F. BC extension intersects this line on point O. So BC extension intersects this line on point O. Do a circle with radius OM and centered on point O. P is a point on the circle. So let's just draw, because the circle would be very large, let's just draw the arc of the circle. It looks like this, right? So let this be the circle. So P is on this circle, and proof angle OPF. So this is P. OPF, this angle, equals to angle OEP. OEP. Right? We want to prove OPF equals to OEP. We notice that the P is any point on the circle. That means this relationship is valid on any point on this circle. So let's think about this problem reversely. Let's assume that this angle, the OPF, equals to the angle OEP. And what we can get from this? We notice that because OPF equals to OEP, and because the angle POF equals to the angle POE, that means the triangle OPF is similar to the triangle OEP, which means if we can prove these triangles are insimilar, then we can prove the angle OPF equals to angle OEP. Means that we need to find another way to prove the similarity of these two triangles. So let's look at the ratio. If these two triangles, the triangle OPF, similar to the triangle OEP, if this is valid, then what we can get from this? We would say OF, the ratio OF to OP, right? OF is a lateral of triangle OFP, and OP is a lateral of the triangle OEP. So this ratio should equals to the ratio of OP to OE. Right? So we want to prove this angle equation. That means we want to prove the similarity of these two triangles. means we want to prove this one because they are sharing the angle POE. So if we can prove the ratio OF to OP equals to the ratio OP to OE, and because we have the angle FOP equals to the angle EOP, then we know these two triangles are similar. So we want to prove this. And we know that OP is a radius, and it equals to the radius of OM, right? OM is a radius. So we want to prove that OF, the ratio OF to OM equals to the ratio OM to OE. Now we need to take a look at what's the ratio of OF to OM. OF to OM need to be equal to OM to OE. We notice that F, M, E, they are all on the line OE, right? And how we get this line OE? We did a parallel line to AD through the point M and intersect the AB on point E and intersect the segment DC on point F. So we know that the parallel line must do something here, help us to prove this equation. And we need to put the ratio in separate equations, which means that we want to find where we can get this ratio, the OF to OM. OF to OM. We know that in the Menelaus theorem, when we have a ratio, we start from a convex and then stop at a intersection point, and then start from that intersection point to the next convex. So here we see that the common point is point O, means that point O, if we want to use the Menelaus theorem, then the point O must be the intersection point, right? So point O must be the intersection point, means that F and M are the convex of that triangle. So if F, M are the convex of the triangle and O to be the intersection point, then where is the line that intersects the triangle, and where is the triangle? Think about this. MF is the lateral, and O is the intersection point. So we can try on this. Look at the triangle DMF and the line BC. Right? Line BC intersects with the triangle DMF on point B for the lateral DM extension, and point C for the segment DF extension, and for the point O on the point O of the segment MF extension. That means we can use the Menelaus theorem, right? We're using the Menelaus theorem to this. So we can get dB divided by, right, start from the convex point to the intersection point, and then intersection point back to the next convex, BM, times M to the intersection point, and O to the next convex, F, times F to the intersection point C, and C to the next convex, CD, equals to 1. now we can see we have MOOF here, and now we want to have MOOE on another equation. So similarly, we do the Menelaus theorem on the triangle AEM and line BC, right? So we got AB divided by EB times EO divided by MO times that's me, so OM, so MC divided by CA equals to 1. Now, because EF is in parallel with AD, so DB divided by BM, DB divided by BM, the ratio of BD and BM equals to the ratio BA and BE, right? Where we find that BA divided by BE is this term, means these two terms, they are equal. And because of the parallel line, we find that in the triangle ACD, FC divided by CD equals to MC divided by AC, right? FC divided by CD equals to MC divided by AC. That means this term equals to this term. So if we divide these two terms, we can get MO to the OF ratio divided EO to the MO ratio equals to 1. That means MO divided by OF equals to EO divided by MO. This means that we prove the equation here, and means that OP divided by OF equal to EO divided by OP, right? And with this equation proved, we know that the angle POF equals to angle POE. So we prove that triangle OPF is similar to triangle OEP. And because of this, we know that angle OPF always equals to angle OEP. This is a computation for the 829 grade, so it's not very complicated, but you need several steps to figure out how the angle relation is actually the relation of the two triangles, and then how we use the Menelaus theorem to prove that. Thank you. See you in next video.